Welcome back. This is the third lesson recording for IM2, January 21st, 2021. So we just started talking about zero product property. So what is a zero product property? To consider this, let's think about what's so special about zero. Okay, when you multiply by zero, what happens? 0 times 3 is going to be 0, and 2 times 0 is going to be 0. Okay, anything multiplied by 0 is going to be 0. It does not matter what you're multiplying. Okay, even if it's x squared multiplied by 0 is going to be 0, as well as 0 times 0 is also 0. So using this fact, we can say that zero product property says that if the product of two terms is 0, then one or both must be 0. This is zero product property. Okay, so if you're multiplying two things, the only way I can get the final answer to be 0 is if one of them is 0, one of them is 0, one of them is 0, or both of the two factors are 0. That's what it means. So if you have 4 multiplied by y is equal to 0, which factor is 0? Well, 4 is obviously not 0, so that means that, and since 4 times 0 is 0, that means y has to be 0, right? Because the only way I can get 0 as the final answer is if y has to be equal to 0. So then we can extend that to if I have 3 times x plus 5 is equal to 0. So we have one factor here, 3, and the second factor, x plus 5 is equal to 0. Then, well, obviously 3 is not equal to 0. That means the second factor, the x plus 5, has to be equal to 0 for it to result in a 0. Okay, so x plus 5 is equal to 0. So we can make that conclusion. And how do we figure out what x is? We subtract 5 from both sides. And so you are left with x is equal to negative 5. And we can certainly check this by substituting negative 5 back into this expression or equation. And negative 5 plus 5 is going to be 0. So that becomes 3 times 0, which is equal to 0. So we can use the fact that zero product property to easily solve quadratic equations. So that's what we are going to be using. So the zero product property says that if the product of the two terms is 0, one or both must be 0, even if those terms are binomials. So if you have x plus 5 multiplied by x plus 3 is equal to 0, the only way this equation becomes true is if the first factor, x plus 5, is equal to 0, or the second factor is equal to 0. Let's deal with the first factor being equal to 0. Then we can say the x plus 5 is equal to 0 and then subtract 5 from both sides. Oh, we don't need the parentheses, so we're going to get rid of the parentheses at this point because we're not multiplying anything. So x plus 5 is equal to 0, and then subtract 5 from both sides, and you get x to be negative 5. Similarly, and then we can test it by substituting it back in, and we do get 0 times x plus 3. So 0 times anything, it does not matter what the second factor is, it's going to be 0, so that comes out to be true. Now let's consider the other option. Okay, what if it was x plus 3 was 0? Because that's also possible. X plus 3 is equal to 0. We set the other factor to be 0, and that means get rid of the parentheses since we don't need it, and subtract 3 from both sides. You get x is equal to negative 3. And again, you can check by substituting it back, and it comes out to be true. So I would like you to take notes on this. How to find the x-intercept of a quadratic equation in standard form. Y is equal to ax squared plus bx plus c. So the step is, first you need to set y to be 0 in this equation, and then factor the quadratic, and then set each factor to be equal to 0 separately, and then solve. So for example, if I have 2x squared plus 5x minus 12 is equal to y, or this is the graph of that, okay? Just as a reference to prove that all that we're doing is correct. The first thing we need to do is factor the left-hand side. So when you factor the left-hand side using either grouping method with diamond or area model with diamond, you're going to get 2x minus 3 multiplied by x plus 4. Okay, so if you get this, then either the first expression 2x minus 3 has to be equal to 0, or the second expression x plus 4 has to be equal to 0. Let's just deal with the 2x minus 3 is equal to 0 first. So that means subtracting or adding 3 to both sides, you get 2x is equal to 3. And then dividing both sides by 2 to get x, you get x is equal to 3 over 2, or 1.5. And that's exactly the x-intercept we have here, 1.5 comma 0. What about the other possibility that the second factor, x plus 4, is equal to 0? So we set that, and we write the equation there, x plus 4 is equal to 0, and then subtract 4 from both sides, and you get x is equal to negative 4, and that is the green x-intercept that you see. Okay? Great, so then let's try to do some problems. Okay, now these problems are similar to the homework. Okay, so you are supposed to find the y-intercept and the x-intercepts of y is equal to x squared minus 2x plus 3. Actually, this is a typo, it should be minus 3. So I am going to correct that. Okay, so it's going to be minus 3. Okay, so now to do this, let's start by doing the y-intercept. What do we know about y-intercept? We know that x-coordinate is always going to be 0. So that means we can find the y value when x is equal to 0. So that's going to be 0 squared minus 2 times 0 minus 3. So 0 squared is just going to be 0. And negative 2 times 0 is going to be 0. And then you are subtracting 3, so you are left with negative 3 here. So that means my y-intercept, the coordinate of y-intercept, the x-coordinate is going to be again 0, y-coordinate is negative 3. Now let's deal with the x-intercept. The first thing we need to do is set the equation, the expression, to be equal to 0, because y is always going to be 0 for the x-intercept. So that means I am going to say x squared minus 2x minus 3 is equal to 0. Instead of y, I am going to put 0, and I am going to factor the left-hand side. The only way I can get x squared is if I split the x and x. I'm looking for two numbers that multiply to negative 3, but that add to negative 2. That's going to be negative 3 plus 1, right? So negative 3 times positive 1 is going to be negative 3, but if I add negative 3 plus 1, that's going to be negative 2. So this works out, and you can quickly check using FOIL. But now that I've done this is where I am going to split the two factors into two separate branches. So that means my first factor is going to be equal to 0, or my second factor could be equal to 0. Okay, now you just solve. You solve by adding 3 to both sides, and you're left with x is equal to positive 3. That means the x-intercept coordinate is going to be 3, 0. And for the other one, you're going to subtract 1 from both sides, and you're left with x is equal to -1. And we know that the y coordinate is always going to be 0, so it's going to be -1, 0. So those are my coordinates. Y-intercept is 0, -3. X-intercepts are 3, 1, and -1, 0. And if I look at the graph, okay, that's the graph. And you can check your work on your homework by going onto desmos.com and using the graphing calculator and just entering this equation, whatever the equation, and it's going to graph all the zeros, all the x-intercept and y-intercept for you. Y-intercept is 0, -3 right here, and x-intercept is 3, 0 and -1, 0, which is what we found. Okay, we're going to repeat the same process a little faster for the next problem. We have a new equation. Y is equal to 2x squared minus 8x plus 6. Then that means for the x-intercept, let's start with the y-intercept. We set the x to be 0. And remember, we know that first term is going to cancel to 0, the second term is going to cancel to 0, and in that case y is going to be +6. So the coordinate for the y-intercept is going to be 0, 6. And that's what we have here. Okay, what about x-intercept? To do that, we set this equation. The y is going to be 0 in this case, because x-intercept always has the y value to be 0. So that's going to be 2x squared minus 8x plus 6 is equal to 0. Now let's factor this. Okay, so we start by doing the diamond. Well, actually, the first thing I should do is factor out the 2 because they're all even. In that case, I don't even need to do the diamond. So that's going to be x squared minus 4x plus 3 is equal to 0. Okay, so then you have 2 here, but we have 2 factors. So that's going to be x and x. We were looking for 2 numbers that multiplies to 3 but add to -4. That's going to be -3 and -1, because -3 times -1 is +3, but -3 minus 1 is going to be -4. So this tells me the first, well, you know that 2 obviously is not 0, but that means either the first factor or the second factor has to be equal to 0. So the first factor is x minus 3 is equal to 0. That means add 3 to both sides, you get x is equal to 3. X minus 1 is equal to 0, or add 1 to both sides and you get x is equal to 1. That means the coordinate of the x-intercept is going to be either 3, 0 or 1, 0. And that's what we have. 1, 0 is the first x-intercept, 3, 0 is the second x-intercept. Okay, another problem. Let's look for y-intercept first. That means we're going to set x to be 0 and y becomes 0 and 0 plus 5. So it's going to be plus 5. So that's going to have the coordinate of 0, 5. And 0, 5 is indeed the y-intercept. What about the x-intercept? That means we're looking for the x squared plus 4x plus 5 to be equal to 0. So the only way we can do that is by factoring x and x here. So we're looking for 2 numbers that multiply to 5 that add to 4. The factors of 5 are 1 and 5. If I add 1 and 5, I get 6. Even if it was negative, it's going to be -6. So this equation is not factorable. And if that is the case, that means there is no x-intercept. And that's what it is. Okay, it does not cross the x-axis at all. So